All right, good morning again, everybody. So, welcome to a Wednesday. Pero totoo ba to? Wednesday pa lang, parang pangbuong linggo na yung pagod natin. And I know everybody is hoping na sana weekend na lang bukas at para makabawi-bawi. We're just halfway through the week. Pero let's just make the most out of it. So today we'll try to finish what we should have finished last week. Kasi medyo delayed na tayo. I think we are 2 sections behind schedule. Pero that's fine. Sabihin ko na lang dun sa midterm committee na kung saan lang yung matatapos natin. So my hope is today we can finish sections 2.5 and 2.6, which is basically Bernoulli's equation and equations that can be transformed to homogeneous form. So basically, yung i-discuss natin ngayon ay dalawang methods na nakita na natin yung basis, o yung basic step. Yan, putol yata ako ron. Pero I was saying that we have discussed the idea behind the core of the two methods that we will discuss today. So basically, parang solutions ng linear first order differential equation where we used an integrating factor, and yung susunod na section 2.6 will make use of the method we developed for homogeneous or for ODEs with homogeneous components. Yun nga lang, yung form ng mga equations na titingnan natin will not directly fall under the required forms ng dalawang methods na na-discuss na natin before. So before we can use those methods that we have discussed last week or 2 weeks back, kailangan muna natin gumawa ng proper substitution before we can implement those methods. So nakikita nyo medyo progressive talaga yung math 151, the way it is designed. So kaya crucial na naintindihan nyo na paano mag-solve ng linear first order differential equation via the use of an integrating factor to be para makasabay kayo sa section 2.5. Tapos kailangan yung tandaan paano nga ba nag-solve ng isang ODE na na homogeneous yung lahat ng components of the same degree para naman makasabay tayo dun sa gagawin natin sa section 2.6. And then I was reading your comments in the last homework na medyo nakakasabay, hindi naman medyo. Most of you said nakakasabay naman dun sa discussion. Ang problema nga lang medyo may anxiety dun sa pag-i-integrate at saka dun sa pag-differentiate. Hashtag ganun din ako. So kaya I am counting on you guys to double check my solutions kasi nga live natin ginagawa. So pakisabi kung meron akong maling integrate o maling derivative on a particular steps. Kaya ginagawa ko step by step din yung solution ko para mas madaling matrace kung saan merong error. And I encourage you guys to also do the same. It's a good habit, I think, that you write everything. So wag mag-skip ng steps. Kasi anyway, you will be told to include necessary steps in your solution. So basically, pagka hindi mo kayang i-mental, malamang kailangan mo siyang isulat sa papel, isama dun sa isasubmit mo na solution. At ako nga kahit kayang i-mental, hindi ko mini-mental. Sinusulat ko siya, tapos kasama na siya ng part ng solution ko. So it's easier to track our mistakes or double check our solution, and also it will help me in grading your work kasi makikita ko yung step by step na ginawa nyo, matitrace ko kung saan may mali, kung meron man, and then I can give you the maximum partial credits na pwede kong ibigay when I know exactly where you got something wrong. By the way, I still owe you, I think, 2 homeworks. Kalahati pa lang yung yata nag-grade ko ng homework 4, pero hopefully lahat ng homework 3 na-checkan ko na. So I'll try to finish that within the week. Yung may mga late submissions, I'll grade it later. Pero don't worry, kung zinero ko na kayo dun sa Canvas pero you send something to me via email, I'll review your email, evaluate if I will accept your work, tapos i-override ko na lang yung 0 nyo sa Canvas. So don't worry, I'll consider them, okay? So also, base dun sa ating survey, hindi tayo babalik sa face-to-face or hindi tayo mag-face-to-face mode after the reading break because there are some of you who voted no. So we will honor the M1 mode for this class. So we will keep this format, except that we will have a midterm exam and pre-final exam pa rin. So kindly make proper arrangements. I know it's a little bit inconvenient and probably costly for some of you. Kasi nakita ko rin yung schedule nyo, medyo ano, no? Medyo iba-iba yung schedule ng mga exams nyo, lalo na kung nagstay lang kayo somewhere far from LB. Kailangan nyo mag-transient or bumiyahe multiple times. Ano? So that's the problem of not having a centralized policy for the entire semester. But we cannot do anything. We're in the middle of it. So yeah. My apologies for that, pero hindi ko kasi siya hawak. Also, may correction nga pala dun sa exam. Tama ba? Ang midterm exam natin ay October 31. Parang ang nasabi ko last time ay October 17. Ano? So it's October 31. That's on Monday. Then I'll give you the details later on. Okay, so that's the Monday after the reading break, right? Okay, so let's get going. I hope those are all the announcements, unless you have some housekeeping concerns. So kung wala, so tingnan natin yung section 2.5. But actually, I think we did one example of this last time. So paano nagsosolve ng Bernoulli's equation? Because essentially, Bernoulli's equation is of this form. Medyo mahaba yung sinabi ng slide. Probably I'll just write something here. So remember, recall na lang muna natin, we have what we call linear first order ODEs. And these are the ODEs of the form dy over dx plus p of x y equals q of x. All right? So ito yung tinatawag natin na ito yung standard form ng isang linear first order ordinary differential equations. And hopefully you remember that if you have an equation of this form, nasulat mo na siya dyan sa standard form na yan, what you can do is to multiply both sides of the equation by what we call the integrating factor. And the integrating factor is essentially e to the integral of p to the power e to the integral of p of x dx, right? So basically, yung integrating factor natin ay integral, ay naka-freeze. How about the others? Kasi sa akin, nakikita ko naman siya. Let me know. Nag-freeze din ba sa inyo? Nakikita naman. How about now, Crizel? Probably I can restart my sharing. Ano? So hold on, guys. Okay, so hopefully, Crystal, okay na. Let me zoom in. Nag-zoom in ba sa'yo? If that didn't work, maybe Crizel, you can try dropping out of the meeting and then joining again. Ano? Okay, so essentially, ito yung pinag-aralan natin last time. So if your equation is linear and first order, that means you can write it in standard form. Importante na isulat mo siya in standard form kasi yung standard form, siya yung magsasabi sa atin ng integrating factor. All right? So in this particular case, our integrating factor is e to the power of the integral of p of x dx. So if you know the exact form of p of x, so isi-simplify nyo lang itong e to the power of the integral of p of x, right? And what we do is we multiply both sides of our differential equation by that integrating factor. So basically, you have e to the integral of p of x dx, dy over dx, plus e to the integral of p of x dx times p of x y equals e to the integral of p of x dx times q of x. All right. And then we do this Ayan, nag-stuck din ba sa inyo? Nag-stuck siya sa ano ko, ako naman yung nag-stuck. Ayun, nag-stuck siya sa aking screen. Ayan, nag-stuck din sa akin. Bakit kaya? Naka-full bar naman ng Wi-Fi ko. Pero let me try this again. Okay. Oops. Alright? So yan, nag-multiply lang ako ng integrating factor both sides. Tapos, why did we choose the integrating factor to be such that it's e to the power integral of p of x dx? Pinili ko siya para yung right-hand side ay maging forma ng ng product rule. Alright? So essentially, we can write this guy as the derivative with respect to x ng integrating factor times y. Right? So pag in-expand nyo to using the product rule, you should get the left-hand side. Tapos equal to sa e to the integral of p of x dx q of x. And then to find y explicitly, kailangan lang nating i-integrate both sides. So ito basically yung idea sa pag-solve ng linear first-order differential equation. Right? But it is crucial that it follows this form. So, dun sa Bernoulli's equation, ganito yung itsura niya. Ang Bernoulli's equation is of the form dy over dx plus p of x y equals q of x times y to some power of n. So, this is what we call a Bernoulli's equation. Okay? So, kung ano man yung value ni n. So, it is almost a linear first-order differential equation except that you have a y to the power n dito sa right-hand side, right? Well, so that means this is not linear kasi meron kang y to the power n. But luckily, we can do a simple substitution trick para maging isa siyang linear first-order differential equation but in a different variable. Okay? So what you do first is we divide both sides by y to the power n. So divide ko both sides by y to the power n. So this would be y to the power negative n. Tapos ito magiging y to the power 1 minus n. Tapos mawawala na yung y to the power n sa right side. So that's the first step. Tanggalin nyo muna yung pampagulo dito na power ni y. And then if you will compare this with this form, we're satisfied with the right-hand side. Okay na siya. Nagmamatch na siya sa standard form na gusto natin. Yun nga lang, yung y dito ay y to the power n dito sa Bernoulli's equation. So what we will do is we will let another variable, say little z, si little z, siya yung gagawin kong y to the power 1 minus n. Para ito, magiging z na lamang. Alright? So ito, magmamatch na dun sa form na gusto natin dun sa second term sa left-hand side. Alright? And then if we compute for dz, this would be 1 minus n times y to the power negative n dy. We differentiate with respect to x. Etong y to the power negative n dy over dx, siya yung pampalit natin dito sa magiging dz over dx na lang to times some constant. So almost meron ka ng dy over dx. So you just need to divide both sides of the equation by 1 minus n. So yun yung idea paano mag-solve ng Bernoulli's equation. Kailangan lang mag-substitution tayo ng z equals y to the power 1 minus n para makuha natin yung, para masulat natin siya in standard form ng isang first order linear differential equation in a new variable, say z. Right? Tapos ito yata yung last example ko last week. So probably we can consider another one para lang ma-refresh tayo. I guess this is the one that I solved last time. Tama ba? Tama, no? Ito yung sinolve natin last time. So I'll show you another example. Okay, let's solve this one. 2x cubed dy equals y times y squared plus 3x squared dx. So first, let's see if we can write it in standard form, or if not, let's hope that this is Bernoulli in form. Okay? So, kailangan sulat ko siya na dy over dx plus p of x y equals q of x. Kung hindi man, yung right-hand side pwedeng maging q of x times the power of y. Okay? So, first I'll divide both sides with by dx. So, solution. I'll divide both sides by dx. So, I'll have 2x cubed dy over dx equals y cubed plus 3x squared y. Okay? Tapos, ita-transpose ko yung 3x squared y sa kaliwa. So, I'll have 2x cubed dy over dx minus 3x squared y equals y cubed. Right? Kasi kailangan yung may coefficient na y, yung may coefficient na y ay nandito. Alright? Kasi nga, ang hinahabol nating form ay dy over dx plus p of x, hopefully, times y equals a function of x. Or kung Bernoulli siya, yung right-hand side, pwedeng may power of y. Right? Kaya iniwan ko na muna yung y cube dito sa kanan. Right? And then I can divide both sides by 2x cubed so that dy over dx will be left alone in the first term. So I'll have minus 3 halves x times y equals 1 over 2x cubed times y cubed. Okay? So essentially, what we have here is dy over dx, that's fine. Our p of x is this guy, dun sa standard form. Tas may y siya na multiplier. This would be our q of x. However, we have a power of y here, so our n is equal to 3. So indeed, this is a Bernoulli equation, all right, with n equals 3. So kapag ka Bernoulli yung equation, kaya natin siyang i-transform into a linear first-order differential equation which can be solved by our good old integrating factor, all right? So again, the first step, eliminate the y to the power 3 from the left, and we can do so by dividing both sides by y to the power 3, right? So I'll have y to the negative 3 dy over dx minus 3 over 2x y to the negative 2 equals 1 over 2x cubed. Okay? And then now I want this to be a single variable, a linear, I want it to be a linear function, or actually not a linear function, but I want this to be a single variable with exponent 1. So ito ngayon, yung ililet ko as my z. Alright? Kasi dun sa standard form, dapat single variable lang to. It's the variable raised, or it's the dependent variable raised to the power 1. So that's what I'll do here. I will let z to be equal to y to the negative 2. Okay, but again, whenever you change the variable, you also change the differential, especially if you're dealing with the dependent variable. So y is the dependent variable. So what I'll do is to change the differential as well. So what I'll do is I'll differentiate both sides with respect to x. So we have dz over dx equals negative 2y to the negative 3 dy over dx, right? Nag-differentiate ako with respect to x. So that means yung y to the negative 3 dy over dx ay mapapalitan ng negative 1/2 dz over dx. All right? So if we go back to our original equation, we have y to the power negative 3 dy dx. Pero alam na natin yung y to the power negative 3 dy dx mapapalitan ng negative 1/2 dz over dx. So here's what we get. So we'll have negative 1/2 dz over dx minus 3 over 2x. Then y to the negative 2 will be replaced by z equals 1 over 2x cubed. So, kompletuhin ko lang yung sentence. So, our ODE becomes this guy. All right? And then I'll divide both sides of the equation by negative 1/2 para ma-isolate si dz over dx para makuha ko yung tamang itsura ng integrating factor. All right? So, I'll have dz over dx. This would be plus 3 over x z. And then this will be negative 1 over x to the third power. Tama ba? Mhm. Mhm. So parang nag-multiply lang ako ng -2 to both sides. I think I got it right. Okay. So now we will have the integrating factor. Thus, the integrating factor is v of x equals e to the integral of p of x. But in this case, our p of x is 3 over x dx, which is basically, lagay ko na lang dito, so which is equal to e to the 3 ln of the absolute value of x plus c, right? In particular, period ko na lang to. In particular, we can consider only positive x's and c equals 0 para makakuha ng isang instance ng integrating factor, right? So if we have these conditions, then our v of x becomes this simpler function. It's going to be e to the 3 ln of x, right? I can write it as e to the ln of x cubed, loss of exponents, so this would be x cubed. So our integrating factor is x cubed. So what I'll do is I'll copy the ODE that we have so far, and then the plan is to multiply this by x cubed, right? Which is the integrating factor that we got. So I'll go next page. This is my ODE from before. I'll multiply both sides by x cubed, which is our integrating factor. So this would be x cubed dz over dx plus 3x squared z equals -1. All right. So now multiply both sides by x to the power 3. And then we chose the integrating factor so that the left-hand side of our ODE or the resulting ODE will be a product of the product rule or a result of the product rule. Essentially, this is the derivative with respect to x of x cubed times z equals -1. And that is by design, right? Kopyahin nyo lang yung integrating factor, tapos instead na dz, magiging z lang siya. And then you can check if you got the right integrating factor, just expand this product using the product rule, right? So the derivative with respect to x of x cubed times z, but we know that z is a function of x because it is a function of y. So basically, ang derivative nito I copy the first, differentiate the second, plus copy the second, differentiate the first. So we get x cubed dz over dx, that's okay. And then 3x squared z, that's that. Essentially, indeed, this is the derivative with respect to x ng x cubed times z. Then all we need to do now is to integrate both sides, or basically multiply ko muna by differential of x both sides. So I'm going to have the differential of x cubed times z equals negative dx. And then I'll integrate both sides. Integral ng differential ng x cubed times z, that will just simply x cubed times z equals integral ng negative dx ay negative x plus the arbitrary constant c. And then I want to have an explicit form. So pwede kong i-divide both sides by x cubed. So we'll have z equals negative x to the -2 plus c times x to the -2. Sorry, x to the -3. Tapos, remember, is z ay y to the what? It's y to the, oops, sorry. Si z ay y to the -2. So babalik ko lang siya kay y. So z is y to the -2 equals negative x to the -2 plus cx to the -3. And you can stop here. That this could be our final answer in implicit form. Hindi maganda na nag-square root kasi pag nag-square root ka, dapat kukunin mo yung plus and minus root. Ano? So you can leave it this way, y to the -2 equals this guy. Or you can take the reciprocal of both sides. So we can get y squared equals 1 over negative x to the -2 plus cx to the -3 if you want. That's also fine. Actually, I prefer this one. Okay. Or kung talaga mapilit kayo, gusto nyo ay implicit form or explicit form, lagyan nyo lang ng plus or minus square root ng 1 over negative x to the minus 2 plus cx to the minus 3. Right? Either any one of these three will suffice as final answer. Okay. Any questions with Bernoulli's equation? By the way, may homework ba tayo ng linear differential equation? Or wala? Sorry. Wala pa, no? Tama nga ba? Gusto niyo ba mag-homework ng linear ordinary differential equation? Hindi. Pagsasamahin natin. Linear ordinary differential equation. Sorry, linear first order differential equation at saka Bernoulli. So Bernoulli na lang yung ibibigay ko. Okay lang ba? Or gusto nyo yung na lang? Pili kayo. Dito sa section 2.5 o 2.6 ang gagawin yung homework for today. Pero I think mas madali itong Bernoulli. So, okay. So sa Bernoulli, okay, try to do one of these guys. So, this could be our homework 6 na nga ba tayo? Homework 6, no? Dami na nating homework. Pero okay lang yan para hindi siya naiipon sa dulo. So let's up homework number 6. Kailan natin to i-due? Today is the what? Today is the 5th. So due, okay lang ba October 12, 9:59 a.m. Okay? So this will be our due date, ano? Oh, pwede ko na palang i-upload yung answer key dun sa mga homeworks, no? Kasi yeah, natapos ko na silang isulat last week. Inantay ko lang yung deadline pero nakalimutan kong i-upload yesterday. But yeah, I'll upload yung mga answer keys hanggang homework number 4. So visit our Canvas website. So I think that's it. Unless you have some questions about Bernoulli's equation. I hope no, I think that example is enough. Kasi nakita na naman natin tong method na to. Meron lang isang nadagdag na step, actually dalawang steps. I-divide both sides by the power of y to the n. Tapos mag-let z equals what? Y to the power 1 minus n. Right? So tapos everything will be according to how we solve a linear first order differential equation. Okay? Is it okay, or if you want one more example? Okay na ba to? Okay, I'll take your silence as okay na siya. Walang nag-request ng additional example. Okay, so let's look at the next topic, which is basically section one more pa para sure. Sige. Kaya lang mababawasan na yung homework items. So, yan natin. Ano yung pwede nating solve? Siyempre, solve ko na yung pinakamadali. Solve ko yung number 2. So, wala na yung number 2. So, ako na yung magsasagot ng number 2. Oops. So, wala na yung number 2 from the homework. So, let's answer this. Talaga yung madali ang pinili ko, no? So yeah, let's solve this one. And basically, nakaforma na siya na dy over dx plus y equals y squared. So basically, our p of x here is 1. Our q of x is also 1. Tapos ang ating n ay equal kay 2. So it is indeed a Bernoulli equation, right? And then again, first step sa Bernoulli equation, tanggalin yung power ni y mula dun sa kanan. So we can do that by dividing both sides by y to the power 2, right? So divide both sides by y squared. We will have y to the negative 2 dy over dx plus y to the negative 1 equals 1. Sayang sinagutan ko yung number 2. Ito na sana yung sasagutan nyo kasi ito yung madali. Pero yeah, dibs ko na yung number 2. Okay, and then gusto natin siyang masulat in the form dy over, yeah, I want it to be in standard form na ganito yung itsura, p of x times y equals q of x. Okay na yung kanan kasi wala nang y na involved dun sa kanan, so that's fine. Problema nating susunod ay ito, yung term na to. Meron kang y to the power negative 1, pero dapat y lang siya supposedly. So what I can do is to change y to the negative 1 to a variable, z, all right, para maging ano na siya, maging linear na lang yung coefficient ng dependent variable. Para hindi na siya maging y to the negative 1 and hope that yung substitution na z will make this a constant times dz over dx. Right? So that's the idea why we do that substitution. So here I will let z to be y to the negative 1 because again, I want this to be just a linear, or this would be the dependent variable raised to the first power. So tawagin ko siyang z. Tatago ko siya sa pangalang z. But I changed the dependent variable. So any change in the dependent variable will entail a change in the derivative, right? So this will be dz, or I'll differentiate both sides with respect to x. So we'll have negative 1, y to the negative 2, dy over dx, because chain rule will kick in. So this means whenever I see a y to the negative 2 dy over dx, it will be replaced by negative dz over dx. And I want to write it this way kasi nakaporma na yan na ganyan. Bernoulli equations are designed to behave this way. Laging ito will be a constant times dz over dx. Kasi kung hindi ganito yung nangyari, hindi siya Bernoulli, you should not have try this solution. So dapat Bernoulli form muna siya bago nyo ginawa itong solution na to. Right? So now we will have negative dz over dx plus y to the negative 1 is simply z equals 1. Okay? And then our integrating factor, so lagay ko na lang sa gilid yung mga yung mga miscellaneous part ng aking solution. So ang ating integrating factor ay v of x equals e to the power integral ng p of x. But here our p of x is the coefficient to z, but that is just 1. Okay? So it's integral ng dx lamang, which is essentially e to the power x plus c, but I'll choose c equals 0. So our integrating factor is reduced to e to the power x. Again, you could choose any constant that you like here. All right? So pero pipiliin ko na lang para mas simple si c ay equal kay 0. Okay? So our integrating factor is e to the power x. I'll multiply both sides of the ODE by that factor. So we'll have bago ko pala siya dapat ginawa. May problema pala ako kasi negative sign pa yung kasama ni dz over dx. I should have divided both sides first by negative 1. Okay. Tapos, so ngayon yung integrating factor ko ay e to the negative dx, which is basically e to the negative x plus c. And then, yeah, yun lang naman pala yung mababago. Kakaroon ako ng e to the minus x. All right. So I multiply both sides by e to the power minus x. So I'll have e to the minus x dz over dx minus e to the minus x z equals negative e to the minus x. And then the integrating factor was chosen in such a way that this guy will be the derivative of the product of e to the minus x and z. So basically, this would be ddx of e to the minus x times z equals negative e to the minus x. All right. And then I'll multiply both sides by the differential of x. So this would be differential of e to the minus x times z equals negative e to the minus x dx. And then we integrate para mawala yung mga differentials, right? So this would be e to the minus x times z equals, what's the integral here? The integral is e to the minus x plus an arbitrary constant c, all right? Ngayon, hindi nyo na pwedeng hindi na kayo pwedeng magbigay ng specific value of C here, right? Because C is really an arbitrary constant corresponding to the general solution, right? So dun sa integrating factor lang kayo pwedeng mamili ng gusto nyo na value ng arbitrary constant. Okay? Kasi kumukuha lang tayo ng isang integrating factor, whereas dito kinukuha natin lahat ng solutions. Alright? Now, I want to isolate z, so I will multiply both sides by e to the power x. So this guy will be 1 plus c e to the power negative x. Sorry, e to the power x pala. All right. And then I'll revert to the original variable. So this is y to the negative 1 equals 1 plus c e to the power x. And then I can stop here and say this is my implicit solution. But if you want to get the explicit solution, you can write this as y equals 1 over 1 plus c e to the power x. Okay? So, bawal nang mag-homework ng problem number 2. Alright? So, ako na yung gumawa ng number 2. Kasi siya yung madali. Sana, sana gumamit kayo ng integration techniques dun sa ibang problems. Ang sama. Gusto ko kayong mag-IBP, ganyan. Pero ako yung mga simple lang na integrals. Okay. So, I hope that's fine. That's sufficient example. At least sa katatlo tayo doon. Actually, dito sa 151, ang matrabaho talaga yung pagpili ng method. Kasi nakakailang methods na ba tayo? Basically, kung bibilangin natin yung mga derivative methods o yung mga methods na related sa iba, I think this is the sixth one, right? 2.6 na yata to. So, pang-anim na method. At marami pa siya. Nakaka-week 5 pa lang tayo. So let's see. Now, in this next set of slides, we will look at ODEs na yung kanyang mga components ay pwede nating ma-reduce to order 0. Right? Kasi before, natutunan na natin kung paano mag-solve ng mga ODEs na yung mga components niya ay homogeneous of the same degree. Alright? So, di ba dati may pinapakita pa tayo na kukunin natin yung m of lambda x, lambda y. Gusto natin itong ipakita na equal kay lambda to the power n ng mxy. Tapos ganun din yung second component, lambda x, lambda y, ay equal kay lambda n to the nxy. This is for an ODE ng itsura ay mxy times dy plus nxy dx equals 0, right? So ito yung sinolve natin dati. Pag napakita natin na si m at saka si n ay parehong homogeneous of degree n, that means these two equations are right or are satisfied, then what we can do here, if you remember, is that we can let y equals xv. Or the other way around, we can let x be equal to yv. But again, we are doing a substitution, a change of variable involving the dependent variable. So kailangan baguhin din natin yung differential. So this will tell us that dy is equal to xv prime, or so x dv plus v dx, right? Tapos when you use this substitution, yung y equals xv, magiging separable na yung differential equation in terms of the variables x and v. Right? So yun yung idea rito. Now, merong mga differential equations na hindi sila homogeneous or yung components niya ay hindi homogeneous of the same order, pero kaya ko siyang isulat in such a way after some substitution na maging homogeneous na siya of order 0. Okay? So yun yung titingnan natin ngayon. Paano ko or aling mga equations yung kaya nating i-reduce into an ODE whose components are all of kaya ko siyang i-reduce into an ODE whose components are all homogeneous of degree 0. Okay? And before we go there, probably you can write this remark. Right? Kung natatandaan niyo yung isang theorem from way back, I forgot the slide number, pero dun sa pag-discussion natin ng homogeneous functions, alright, meron tayong theorem na kapag ka si M is homogeneous of degree 0, then it can be written as a function of y alone. Sorry, of y over x alone. M is a function of y over x alone. And I think we have written a proof for this one, right? Kapag kasi M ay homogeneous of degree 0, then kaya natin siyang isulat as a function ni y over x lamang, right? So we can change the variable, call v equals y over x, and then all that we will see would be the variable v's inside the function M. And we will capitalize on this fact, na kapag ka siya ay homogeneous of order of degree 0, dapat function lang siya ni y over x. Okay. So let's see the general description of the method before solving particular examples, right? So ito yung sinasabi ko in equation 5. Hindi ko alam kung bakit equation 5 yung pangalan sa slides. Pero hindi ko kasi ma-edit yung equations dun sa slide kasi math type siya. Wala akong license ng math type. So hindi ko siya ma-edit. Pero let's call it equation 5 nevertheless. So kapag ang components ng isang ODE ay homogeneous of order 0, or actually not order, it should be degree 0. Okay. Kaya natin siyang isulat ng ganitong itsura. dy over dx equals f of y over x. Because again, if your function f is homogeneous of degree 0, kaya natin siyang isulat as a function of y over x alone. Okay? And then if that is the case, then yung right-hand side na to ay homogeneous na talaga of order 0. Kasi pag pinalitan natin to ng lambda y over lambda x, magiging f of y over x lamang siya. So ibig sabihin, hindi naapektuhan ng stretching and shrinking yung function f natin. All right? And then if this is the case, we can easily solve this by letting y be equal to xv. Alright? So ito yung substitution na kailangan natin. Tapos when we do this substitution, magiging separable na yung differential equation na kailangan. Pero again, the requirement here is that the right-hand side, the function little f, should be a function of y over x alone. Pero in general, hindi yun nangyayari. Alright? So posible na linear function ni y over x yung numerator at denominator dun sa loob ni function f. So we will look at general expressions of this form. Y prime equals a1x plus a2y plus a3 over b1x plus b2y plus b3. So halimbawa, ito yung involved dun kay function f. Ang gusto kong mangyari, masulat sana to as f of, say, alpha x, alpha 1x plus alpha 2y over beta 1x plus beta 2y. Sana, ito yung pangarap ko, sana mawala yung A3 at saka yung B3. Alright? Kasi pag nawala yung A3 at B3, so basically nagkaroon lang ako ng ibang constant times x plus ibang constant times y. Yun yung alpha 1x ko at saka alpha 2y dito sa right-hand side. Tapos ganun din, kung matatanggal ko yung B3 by a change of variable so that this entire trinomial will be reduced to beta 1x plus beta 2y, pwede ako ngayon mag-divide ng x dun sa numerator at saka sa denominator. So pwedeng mangyari, masulat ko to as alpha 1 plus alpha 2 y over x plus beta 1 plus beta 2 y over x. And now this guy is simply a function of y over x. So gagana na ngayon yung substitution na natutunan natin mula dun sa homogeneous o dun sa ODE na homogeneous yung components. Because now our function f, ang itsura ng mga variables na nakikita ko na lang kay function f ay y over x. Kasi si alpha 1, si alpha 2 ay constants, si beta 1 at saka si beta 2 ay constants. So basically, ang variable lamang kay f ay itsurang y over x. Kaya ko siyang isulat in such a way na wala akong makikita na x na nagsosolo, wala akong makikita y na nagsosolo, basta may variable, laging ang itsura ay y over x. And that's the goal. All right? I need to find a way on how to eliminate the unwanted constants in the numerator and the denominator, which will allow me to write the function in terms of the variable y over x, albeit the very different constant alpha 1 and alpha 2, and beta 1 and beta 2. So ang idea ay ganito. Gusto ko mawala si A3 at saka si B3, so I wish to find, okay, sulat ko sana WTF, pero baka ma-censor ako, no? So, we want to find this, all right? So we want to find a constant x sub 0, such that a1 x sub 0 plus a2 y sub 0 plus a3 ay 0, tapos b1 x sub 0 plus b2 y sub 0 plus b3 equals 0. Gusto kong makahanap ng x0 at saka y0 na totoo ito. Alright? Kasi pag alam ko, pag nakahanap ako ng x sub 0 at saka y sub 0 that satisfies this system of linear equations, ano? So then I can use the substitution x bar equals x minus x sub 0, x, hold on, inisip ko kung x plus or x minus. It should be, it should be x minus x sub 0. Ginawa akong tama. Yeah, it should be x minus x sub 0 and y bar equals y minus y sub 0. So mag-change ulit ako ng variable dito. So si x bar gagawin kong x minus x sub 0, saka si y bar gagawin kong y minus y sub 0. So this means si x ay pwede kong palitan ng x bar plus x sub 0, tapos si y papalitan ko ng y bar plus y sub 0. Okay? Now, if we go back to what is inside our original function, tingnan nyo to. So yung x dyan, papalitan ko ng x bar plus x sub 0, tapos yung y papalitan ko ng y bar plus y sub 0. So I'll have a1 times x bar plus x sub 0 plus a2 times y bar plus y sub 0 plus a3, right? And then I simplify. I'll have a1 x bar plus a1 x sub 0 plus a2 y bar plus a2 y sub 0 plus a3, all right? Pero look at these terms. a1 x sub 0 plus a2 y sub 0 plus a3. Saan equal to? By design. Saan equal yung mga naka-highlight? Yes, Dino is right. Equal siya kay 0. Kasi yun nga yung requirement ko kay x sub 0 at saka kay y sub 0. Right? So this trinomial should be equal to 0. So itong tatlong terms na yan altogether will be equal to 0. So what we'll have left is a1 x bar plus a2 y bar, which basically nasatisfy ko na yung gusto kong mangyari, na ito ay pwede kong isulat as 1 over x bar times a1 plus a2 y bar over x bar. Right? Tapos ganun din yung mangyayari dito sa denominator. Pag pinlog-in ko yung x bar, magkakaroon naman ako ng b1 x bar plus b2 y bar. Okay? Yes, that's it. Right? Tapos pwede kong i-factor uli yung 1 over x bar. So magkakaroon ako ng 1 over x bar ng b1 plus b2 y bar over x bar para dun sa variable sa denominator. Tapos yung 1 over x bar ng taas at saka baba magka-cancel each other out. So we will have something of this form. Tapos, homogeneous na siya of degree 0. So pwede ko na nga yung i-apply yung mga natutunan natin mula dun sa chapter ng homogeneous components ng ODE. Right? But all of this rests on finding an x sub 0 and y sub 0. Dapat makahanap muna tayo ng solution x sub 0 at y sub 0 dito sa linear system na yan. But when we have that solution, everything will be fine. We can do the substitution and then appeal to the method that we have discussed last time, right? Siguro it would be clearer if we look at particular examples, So, mahaba yung discussion ng method, pero I hope you get the idea. And usually it's clearer if we look at particular examples, Okay, let's try this one. As an exercise, you can try to show that this is not homogeneous, all right, or the components of this ODE are not homogeneous. So kailangan ko muna siyang i-transform for it to become homogeneous, right? So you can think of it as y prime equals f of y plus 1 over x plus 2. Right? Kasi ang mga variables na nakikita natin lagi dito ay y plus 1 over x plus 2 at saka y plus 1 over x plus 2. Right? So kaya ang function f natin ay this guy plus exponential of something. Right? Oh, by the way, when we say exp of something, this is the same thing as e to the power y plus 1 over x plus 2. Pag medyo komplikado kasi yung exponent, ang hirap isulat nito, ang laking space yung kakainin. So what we do is usually write it as exp na lang. Parang tipong MATLAB din yung pagkakasulat niya. Alright? So basically, ito yung function natin. So yung mga variables na sinasubstitute lagi dyan, lagi magkasama yung y plus 1, tapos naka-divide by x plus 2. So indeed, we'll be looking for constants such that y plus 1 will be equal to 0 and x plus 2 will be equal to 0. Or y sub 0 plus 1 equals 0 and x sub 0 plus 2 will be equal to 0. Okay, so that would be the first part of our solution. So solution, we look for an x sub 0, y sub 0 that are real numbers such that we have this system. We want y sub 0 plus 1 equals 0 and x sub 0 plus 2 equals 0. Which is easy because we have a linear system that are independent, where the equations are independent from each other, right? So walang x sa unang equation, walang y sa pangalawang equation, so we can solve these two equations independently, all right? So that means we can have x sub 0 equals negative 2 and y sub 0 equals negative 1. Sila yung magpapa-0. Kaya sila yung magpapa-0 dun sa trinomial na supposedly gusto natin gawin, But I was thinking probably there's a shortcut here. I can divide both sides by x, 2 over x. Ay, hindi mag-work yung shortcut na inisip ko. Alright? So basically now, ito yung meron tayo. So ang mangyayari ay ganito. So I will let x bar to be equal to x minus x sub 0, right? So I will let x bar be equal to x minus x sub 0. So this would be x minus negative 2. So this would be x plus 2. And y bar equals y minus y sub 0. But y sub 0 is negative 1. So our y bar will be equal to y plus 1. Okay? So this means our x is actually x bar minus 2 and y equals what is y? Y bar minus 1. Okay? So hence our ODE becomes this. So kailangan ko palang palitan yung y prime kasi si y prime ay dy over dx. Alright? So kailangan malaman ko ano yung pampalit kay y prime kasi ngayon magbabago tayo ng variable. Instead of the independent variable y, we will have the independent variable y bar. Okay. So that means from here, kailangan ko pang gawin yung differentiation. So I will differentiate both sides with respect to x. So I'll start here. I-differentiate ko with respect to x. So magkakaroon ako ng derivative ni y bar with respect to x. Actually, magkakakulang ako dito. Kailangan ko palang i-take note muna ito. Gamit na lang ako ng chain, what do you call this? Gamit ako ng chain rule. So note that yung dy bar, hindi pala ako pwedeng mag-differentiate lang with respect to x. Kasi pag nag-differentiate ako with respect to x, mahanap ko yung pampalit ko sa dy over dx. Okay? Pero ito ay magiging dy ODE, di ba? Kasi ang ating ODE magiging y bar na lang at saka x bar yung variables. So this substitution or this differentiation will not make sense, right? Hindi ako pwede mag-derivative lang with respect to x because I want to have is the derivative of y bar with respect to x bar. Ito yung gusto kong maging derivative dun sa ating ODE. So kailangan hanapin ko saan equal yung dy bar over dx bar. The derivative of y bar with respect to x bar. Okay? But chain rule tells us this is the same as dy bar with respect to x times dx with respect to x bar. All right? So this is basically your chain rule for derivatives, right? Madali siyang tandaan kasi sort of nakakancel yung dx, matitira ay dy bar over dx bar, which is the right-hand side. Okay? So let's see. Why did I choose to write it this way? Kasi yung dy bar over dx madaling i-compute. Because I know what y bar is. I know that y bar is equal to y plus 1. Tapos para makuha itong first factor na to, kailangan ko lang i-differentiate si y bar with respect to x. But again, y bar is equal to y plus 1. So the derivative of y bar with respect to x is the same as the derivative of y plus 1 with respect to x. And the derivative would be dy over dx plus 0, right? Differentiate ko lang to with respect to x. Times, second factor would be the derivative of x with respect to x bar. So, hanap tayo ng equation involving x and x bar. We have this guy. Right? Kulayan ko siya ng green. Ito naman yung meron tayo. X equals x bar minus 2. Siya yung gagamitin ko para makompute yung dx over x bar. I have an expression for x in terms of x bar minus 2, in terms of x bar. I want to get the derivative of x with respect to x bar. So gagawin ko lang, i-differentiate ko both sides with respect to x bar. Okay? Derivative of x with respect to x bar is exactly dx over dx bar. Derivative ni x bar minus 2 with respect to x bar ay 1. Right? So yun naman pala, madali yung substitution. Si dy bar over dx bar ay equal lang kay dy over dx. And this is expected because ano ba yung ginawa natin kay variable x at saka kay variable y? Si variable x at saka si variable y, binawasan lang natin by some constants, right? Yung constant translation, wala siyang epekto dun sa differentiation. Kaya understandable na yung derivative ni y bar with respect to x bar, si y bar, shinif lang natin yung variable y some units to the left or to the right. The same goes for x bar. Yung shifting, yung translation to the left and to the right, wala siyang epekto sa derivative. So kaya dy over dx pa rin siya. Okay? So this means the dy over dx in our original ODE will be replaced by dy bar over dx bar. Okay. So hence, etong y bar na to, itong y prime na yan, magiging dy bar over dx bar pa rin siya equals, okay, equals y plus 1, all right? But we already let y to be equal to y bar minus 1. So that would be y bar minus 1 plus 1 over si x, papalitan ko ng x bar minus 2. Pero may plus 2 pa na natira. Plus exponential of the same guy. Okay? And then simplify, magiging ano na lang siya, magiging y bar over x bar plus exponential ng y bar over x bar, dy bar over dx bar. And this is now a what? this is now homogeneous of degree 0. All right? Or actually, equivalently, this is now simply a function of y bar over x bar. Kasi kapag ka nakakita ka ng variable, laging magkasama yung y bar over x bar. Walang nagsosolong variable, so you can say that this is indeed a function simply of y bar over x bar. Okay? And basically, you can also show that this is a homogeneous of degree 0. Kasi kung ito si f, pag pinalitan mo lahat ng y bar ng lambda y bar, tapos lahat ng x bar, pinalitan mo ng lambda x bar, ma-reduce lang uli siya dito. You end up with the same expression, right? Kasi pag pinalitan mo si y bar ng lambda y bar, si x bar ng lambda x bar, so ganun din dito, ma-cancel to, ma-cancel yan, ma-cancel yan, ma-cancel yan, you end up with the same equation, right? So essentially what I'm saying is that f of lambda y bar over lambda x bar ay equal then kay lambda to the 0 f of y bar over x bar. So essentially siya ay homogeneous of degree 0. Tapos alam na natin kung paano nagsosolve ng mga equations na homogeneous of degree 0 yung kanyang components, right? So meron lang tayong substitution na ginagamit, which is either y equals xv or the other way around. Okay? Pero dito, papangatawanan ko para mas madali, I will let what? Gusto ko ay yx over b. Y bar over x bar equals v. So ang gagawin ko ay y bar equals vx bar. And then again, I'm tinkering with with the dependent variables. So ibig sabihin may nakaakibat pa rin yan na change in the differential. So I'll have dy bar equals or actually kunin ko na yung derivative ni y bar with respect to x bar, right? So ito i-differentiate ko ngayon with respect to x bar. So ang derivative niya with respect to x bar ay v times 1 plus x var dv over dx, right? So kailangan ko mag-product rule kasi si v ay function din ni x bar, right? So I take the derivative both sides of x bar. This being a function of x bar requires the product rule. So derivative niya ay v times derivative ni x bar with respect to x bar. So that's how I got v times 1 plus x bar times derivative ni v with respect to x bar. So may x bar pala siya doon. Okay? Andyan pa ba kayo guys? Ang daming substitution na nagaganap, ano? Pero hopefully you can follow and you see the idea kung bakit ko ginagawa yung mga substitution. Kasi pwede nyo sauluhin lang yung mga methods. Ano? Kung magaling kayo magsaulo, sauluhin nyo yung method na pagka ganito yung itsura, maglilet ako. Pero it would be better if you know the idea behind the methods para alam nyo kung bakit ka nagsasubstitute. Para hindi nyo siya kailanganing sauluhin. Kasi hindi ako magaling magsaulo. Kaya ayoko yung 151 ng undergrad eh. Kasi sinasaulo ko lang talaga siya ng undergrad. Ngayon nagtuturo na ako, hindi ko na siya kailangan sauluhin. Kasi iniintindi ko na lang bakit ito yung substitution na ginagamit. Right? So para matrace ko yung step na susunod mula dun sa previous step. Right? So we do these things. dy bar over dx bar will be replaced by this guy. So we're gonna have v plus x bar dv over dx bar as our left hand side. And then the reason why I chose y bar to be vx bar is that so that y bar over x bar will be simply the variable v. So magiging v na lang to plus e to the v. Madali na siyang isulat na e to the v. And then dapat maging separable na to. Ito yung promise ng homogeneous, right? After you do a substitution of this form, this should reduce into a separable differential equation, right? So separable nga ba siya? Well, I can subtract v from both sides. So we're going to have x bar times dv over dx bar equals e to the power v. And then I'll multiply both sides by dx bar over x bar and then divide by e to the v. So is it correct? I'll have e to the negative v dv equals dx bar over x bar. Right? Tapos ayan, separable na siya as promised. Kasi nga, after the substitution, we have transformed all the components to be homogeneous of degree 0. Right? So all we need to do now is to integrate both sides. Yay, madali yung integration. Di ako mahihirapan. Right? So integral ng e to the negative v dv ay negative e to the minus v plus an arbitrary constant which I'll just add to the other side. So ito ay magiging ln ng absolute value ng x bar plus the arbitrary constant c. Okay? And then babalik na lang ako sa variable na x at saka sa y, right? Pero siguro dahil si v, ito ay may laman na variable, pero andun pa siya sa exponent, so pwedeng kunin ko na lang muna yung ln ng parehas na sides, right? So what I can do is first multiply both sides by -1. So I'll have e to the negative v equals negative ln ng x bar minus c. Or pwede ko na lang siyang gawing plus k. Kasi yung negative naman walang epekto dun sa arbitrary constant. Tapos I'll take the ln of both sides. If I take the ln of both sides, I'm gonna have negative v equals ln ng negative ln ng absolute value ng x bar plus k. Tama, no? Kinuha ko lang yung ln ng both sides. Tapos divide by -1. Kakaroon ako ng negative dun sa kabila. Tapos I'm ready now to go back to the original variables. Remember, v is y bar over x bar. Y bar over x bar is equal to this guy. Duplicate ko na lang to. So tapos, babalik ako ngayon sa x at saka sa y. Pero I can multiply both sides muna by x bar. So I'll have y bar equals negative x bar times ln, and negative ln ng x bar plus arbitrary constant k. And then I'll revert to the very original variables. So remember, y bar is what? Sorry, kailangan kong balikan. I have the memory of a goldfish talaga. So kailangan kong bumalik. So ang y bar natin ay y plus 1 at ang x bar ay x plus 2. So babalik ko lang yung variables. So ang y bar ay, ano nga? So tingnan nyo, limot ko na nga. Ang y bar ay y plus 1. Tama ba? And then ang x bar ay x plus 2. So this would be negative x plus 2 times ln ng negative ln ng absolute value ng x plus 2 plus the arbitrary constant k. And then if you want to get the implicit form, this is essentially y equals -1 minus x plus 2 ln ng negative ln ng absolute value ng x plus 2 plus k. And that's our final answer. Kapagod. Daming substitution na naganap. All right. Is it okay? Questions? O dina-digest niyo pa? So buti na lang, ang pinili niyong homework ay Bernoulli. Kasi medyo mahaba-haba itong equations na reducible to homogeneous of degree 0 yung right-hand side. Okay? Pero crucial dito, dapat may solution. May solution yung linear system na gusto niyong gamitin. Right? So siguro let's have a 1-minute break. Tapos 11:13, simulan ko yung susunod na example. We might not finish it by 11:20, pero itutuloy ko siya on Thursday. Okay? So para lang meron time to digest whatever we have, right? Mag-water break sana, kaya lang naubos ko na pala yung tubig ko. Pero sige. Ayos pa ba kayo dyan? Okay, good. Nakapag-review na ba kayo ng techniques of integration, ano? Ano ba mga usual techniques of integration? IBP, partial fraction decomposition, ano pa ba? Powers of trigo. Bihira tayo nagpapatrigo sa bihira rin ng algebraic substitution. Ano pa nga ba? Yeah, I think those are the usual integration techniques na nakita nyo, no? So yung apat na yun yung mga pinaka-crucial. Pero ang gamit talaga ay IBP at saka partial fraction decomposition. Okay? Okay, for the last 7 or so minutes, let's start another example. Okay, ito naman. 2x minus y dx at saka 4x plus y minus 6 dy. Okay, so I'll try to write it in the form dy over dx equals a function of a1x plus a2y plus a3 all over b1x plus b2y plus b3 para makita ko ano yung linear system na kailangan kong isolve para ma-reduce siya into an ODE with homogeneous components. Okay? So I'll divide both sides by, or I'll rearrange the terms and then I'll divide both sides by 2x. Anong papandivide ko? I'll divide both sides by 4x plus y minus 6 dx. So I'll have what? I'll have dy over dx equals negative ng 2x minus y all over 4x plus y minus 6. Okay? So, tama ba ito? Double check. Okay? Tinranspose ko yung 2x minus y sa kabila times dx, tapos nag-divide ako both sides by dx, tapos nag-divide ako ng 4x plus y minus 6. Alright? So, ito yung itsura. So, essentially, we have a function of 2x minus y over 4x plus y minus 6. Ngayon, so ito yung f ko. Ito yung f of 2x minus y over 4x plus y minus 6. So we'll be looking for, so we want to find x0 and y sub 0 that are real numbers such that totoo tong system na to. And 2x minus y ay equal kay 0 and 4x plus y minus 6 ay equal kay 0. Yan yung gusto kong isolve, ano? But I will do substitution here. Elimination here. So ang gagawin ko yung negative 6 nito, ililipat ko na dun sa kanan. Right? So magiging equals 6. So that means I can multiply the first equation by negative 2 para ma-eliminate ko yung variable x. So I'll have minus 4x plus 2y equals 0. So may multiply ko by negative 2 yung first equation. Then retain yung second equation. And then I'll add the two equations. I'll have 3y equals 6. So that means y equals 2. Okay. And then from here, I know y is equal to 2. So substitute ko siya sa first equation. I get 2x minus y equals 0. Plug in y equals 2. So we'll have 2x equals 2, x equals 1. Right? So ito yung dalawa nating constants na magpapa-0 doon sa 2x minus y at saka sa 4x plus y minus 6. So what I'll do now is to let x bar be equal to x minus 1 and y bar be equal to y minus 2. All right? And then that means ang x ay equal kay x bar plus 1 and ang y ay equal kay y bar plus 2. Okay? And also, this means that dy bar over dx bar, but this is equal to, according to the chain rule, dy bar over dx times dx over dx bar ay equal lamang kay derivative ni y bar with respect to x. So derivative ni y bar with respect to x. So this will just be dy over dx times derivative ni x with respect to x bar. Derivative ni x with respect to x bar equal lang kay 1. So dy over dx pa rin siya. Okay? So I think we have all the ingredients para dun sa ating ODE. So copy ko lang to. You can take a screenshot now, no computations, and then I'll shift to the next page. Okay. Shift to the next page. Here's what we got. Pero I know that dy over dx is basically dy bar over dx bar by design kasi nga tinranslate lang natin yung variables. But this time we'll have negative of 2 times x is what? X is x bar plus 1. X bar plus 1 minus y, but y is y bar plus 2 all over 4 times x bar plus 1 plus y bar plus 2 minus 6. Okay. And then we expand. So we'll have minus 2x bar plus 2 minus y bar minus 2 all over 4x bar plus 4 plus y bar plus 2 minus 6. All right. And then again, we did the substitution or the translation of the variables so that mawawala yung constants. Okay lang yung numerator kasi wala na siyang pero itong denominator constant na negative 6. Where tapos yung y, pinaltan mo ng lambda y, alright? Hindi mo ma-factor out yung lambda. Kasi itong 6, wala siyang lambda na kasama. Yun yung problema, kaya hindi siya homogeneous of degree 0. Okay? But now, I think we can do this. Ayan, lumabas din yung annotations, pero delayed pa rin yata. Delayed din ba sa inyo yung screen ko? Okay naman. Okay, now I simplify this. So we'll have dy bar over dx bar equals minus 2x bar minus y bar. Okay. Meron kasing plus 2. Tapos dun sa baba, 4 plus 2 minus 6. So magiging 0 lang din yung constants doon. So magkakaroon ako ng 4x bar plus y bar. And now you can see that this is homogeneous of degree 0. Pag yung x's, pinalitan mo ng lambda x. Pag yung y bars, pinalitan mo, pag yung x bars, pinalitan mo ng lambda x bar. Pag yung y bars, pinalitan mo ng lambda y bar, makikita mo to ay homogeneous of degree 0. Okay? Actually, you can write this as negative 2 minus y bar over x bar over 4x, over 4 minus plus y bar over x bar. Hindi na lang konti yung lag. Bakit kaya? Hopefully yung audio ko ay hindi pa putol-putol. Baka magkaibang wifi yung kinonekta ng laptop ko sa nung iPad ko. So, yeah. Sulat ko siya dito. What happened is I factored out 1 over x sa top, tapos 1 over x din sa bottom. Tapos magka-cancel lang naman yung mga 1 over x, kaya nasulat ko siya in this way. All right? I want to work with this form because what I'll do is I will let I will let y be equal to vx, all right? So that means that v is just y over, may mga bars pala yung mga variables. So lagi ko nakalimutan yung mga bars. And then this also means that dy bar ay equal kay v dx bar plus x bar dv, right? So chain rule ulit. So substitution, so I'll have Kailangan ko pala dy bar with respect to x bar. So hindi ko pala kailangan yung differentials. Sorry. Kasi ito yung gusto kong palta, no? dy bar over dx ay equal dito. Derivative ni y bar with respect to x. So ito na yun. So mag-chain rule ako. So what will happen is I'll have v, that's 1, plus derivative ni v with respect to x bar times x bar. So ito yung magiging dy bar over dx bar natin. Tama ba? Hold on. Habang nagka-catch up yung screen ko, double check. Dy over dx. So let's just put this into our ODE. So hence we have the following. dy bar over dx bar is v plus dv over dx bar times x bar equals negative ng 2 minus v over 4 plus v. Okay? Or we'll have dv over dx bar, x bar, equals negative v minus 2 minus v over 4 plus v. Tapos, anong susunod? Oops. Ipoporma ko lang muna siya para bago tayo mag-dismiss. Copy ko lang to sa kabila. Okay. Tapos, how do I do this? So I'll have dv over negative v minus 2 minus v over 4 plus v equals dx bar over x bar. All right? So ito yung i-integrate natin pagdating natin sa Friday. Okay? Integrate it. Just simplify the denominator first. Tapos simplify mo lang yung denominator dito. Yung entire fraction dito. You'll need to do partial fraction decomposition. Okay? Tapos ito madali lang naman to kasi ito ay ln lang ng absolute value ng x bar. Okay? But we'll continue on Friday. So let's stop here. Sorry, overtime ako ng 5 minutes. Do you guys have any questions about this? I know it might take some time for you to digest this, pero I hope yung steps ay nagme-make sense, at least yung general idea. And again, this will you will need to get your hands dirty. Ano? So mahirap matutunan yung 151 if you don't get your hands dirty by answering some problems. Kaya maraming exercises na nakalagay dun sa dulo nung slides, ano? And kaya siguro damihan din natin yung homework para masanay kayo. Tapos hindi na tayo magpa-problem set kasi every day naman meron kayong homework which is due 1 week after, no? Okay, any questions, clarifications, parting words?
Sir, ako po, parang clarify lang po. So, by
Okay, go.
default, kapag ginagamit po or tina-translate natin yung dy bar all over dx bar, palagi ba siyang dy all over dx?
Yes. You mean this, no? Yeah.
Apo,
Lagi
since
siyang
lagi nating sinosolve, so lagi bang yung itsura niya is dy dx dapat at the end? Ganun.
Yep. So lagi
Okay po.
yeah. You can just remember it. Dy bar over dx bar is equal to dy over dx. Pero minsan kasi hindi ako nagtitiwala sa mga sinasaulo ko. Kaya laging sinosolve ko to paulit-ulit. Pero Dino is right. That's the pattern. Dy bar over dx bar is always dy over dx precisely because si y bar lang naman, inisod ko lang yung y components by some units. Tapos yung x bar naman, inusod ko lang yung x by some units. Nag-ano lang naman ako, nag-subtract ng constant. So that will not change the differentials. So this is good. Laging ganito yung itsura na. Okay? So you can skip this and sabihin nyo na lang yung dy bar over dx bar na papalitan ng dy over dx. Pero at least this time, at least twice ko na siya inulit. Alam nyo na kung bakit yung dy bar over dx bar ay napapalitan ng dy over dx. Okay? Yeah, thank you for that nice question, Dino. Any other questions? Okay, so if there are none, so pakitandaan, tutuloy natin tong solution na to. Although partial fraction decomposition na lang naman to yun sa klase. Or bigay ko na lang yung final answer kasi sinolve ko na yung kagabi. Actually, yun na pala yung end nito. Yeah, exercises na ulit. Okay? So siguro let's continue na lang para rin ma-review tayo ng partial fraction decomposition and it would be a good introduction next time. Ang susunod yata ay substitute probably. So watch out for that. And until then, keep safe, guys. Enjoy your lunch, and let's see each other again on Friday. Bye, everyone.